So in this problem, we have to show that in any triangle ABC, sine cube A times cosine of B minus C added to sine cube B times cosine of C minus A plus sine cube C times cosine of A minus B equals 3 times sine A, sine B, sine C. So let us begin. So we're going to start from the left-hand side of a given problem. So on the left-hand side here, we have sine cube A multiplied to cosine of B minus C, but we're going to rewrite it as sine squared A multiplied to sine A times cosine of B minus C. Then we have the second term, so we have sine cube B, which can be expressed as sine squared B multiplied to sine B times cosine of C minus A, added to the third term, which is sine squared C multiplied to sine C times cosine of A minus B. So this is our left-hand side. Now the reason why we have written in this particular fashion, because we're going to replace the value of sine A, sine B and sine C. Now we know that in any triangle ABC, the sum of the interior angles, which is A plus B plus C, they sum up to 180 degrees or pi radians. Meaning, we keep A plus B on the left-hand side and transpose C to the right-hand side. And when we take the sine on both sides, we get sine of A plus B. So that will be equals to sine of pi minus C. So sine of A plus B will be equals to sine pi minus C. We know that its value is sine C. So we have obtained the value of sine A plus B, which is also equivalent to sine C. Similarly, we can also say that sine of angle B plus C, so that will be equivalent to sine of angle A, and sine of angle C plus A, that will be equals to sine of angle B. So let's replace this value here. This is going to give us now sine squared A multiplied to sine A. So sine B will be replaced with sine B plus C multiplied to cosine of B minus C, plus the second term. So here we have sine squared B multiplied to sine B. So sine B will be replaced with sine C plus A, and that's multiplied to cosine of C minus A. Then coming to the third term, so here we have sine squared C multiplied to sine C. So sine C will be replaced with sine of A plus B multiplied to cosine of A minus B. Now what we'll do, we're going to use some formula here. So we're going to multiply each term with 2, and then we're going to divide by 2. So let's do that to each the second term as well. So we're going to multiply by 2 and divide by 2, as well as do this to the third term, multiply by 2 and divide by 2. The reason why we have done this, because now we can combine 2 times sine B plus C times cosine of B minus C. Now this is going to give us half sine squared A. So the combination of 2 times sine B plus C times cosine of B minus C, so that's equivalent to sine 2B plus sine 2C. Coming to the second term, so we have half sine squared B multiplied to 2 times sine C plus A times cosine of C minus A, so that's sine 2C plus sine 2A. Right. And the third term will be half sine squared C multiplied to sine 2A plus sine 2B. Fine. Now we're going to expand sine 2B and sine 2C, because we are going to use the fact that sine 2 theta, we know that that's equals to 2 times sine theta times cosine theta. So we're going to use this to expand each of the terms within the parentheses. So we have half sine squared A multiplied to, we have sine 2B, so that will expand to give us 2 times sine B times cosine B. Then sine 2 is going to give us 2 times sine C times cosine C. Coming to the next term, we have half sine squared B multiplied to sine 2C. So sine 2C will be 2 times sine C times cosine C, plus sine 2a, so that's 2 times sine a times cosine a. And in our third term, we have half sine squared c multiplied to sine 2a, so that's 2 sine a times cosine a added to sine 2b, which will be 2 times sine b times cosine b. Now, from each of the two terms, we can factor out 2 and we can cancel it out with the 2 in the denominator. So that's going to give us sine squared a. So we're also going to multiply sine each of the terms with sine squared a for the first term. So we have sine squared a multiplied to sine b times cosine b. Then we have sine squared a multiplied to sine c times cosine c. Then we have sine squared b. So this will be multiplied to sine c times cosine c. Then we have sine squared b multiplied to sine a times cosine a. And we have sine squared c multiplied to sine a times cosine a added to the final term, which will be sine squared c multiplied to sine b times cosine b. Now what we're going to do, we're going to combine this term and this particular term by taking sine a times sine b as the common factor. So sine a times sine b, this will get multiplied to, so we have sine a times cosine b. This is from the first term. Then from the fourth term, we'll be left with sine b times cosine a. Then we are going to combine the second term with the fifth term by taking sine a times sine c as the common factor. So from the second term, we'll be left with sine a times cosine c. And from the fifth term, we'll be left with sine c times cosine a. And then finally, we're going to combine the third and the sixth term by taking sine b times sine c as the common factor. So this will get multiplied to sine b times cosine c plus sine c times cosine b. Right. Now we know that sine a cosine b plus sine b cosine a, that is nothing but, so let's first write down sine a times cosine b. So this will be now multiplied to, so this is the expansion of sine a plus b, plus we have sine a plus sine c multiplied to the expansion of sine c plus a. And in the third term, we have sine b times sine c multiplied to the expansion of sine b plus c. Now we've already defined that sine a plus b, that's equivalent to sine c. So here we've already found, and sine b plus c, that's equivalent to sine a, and sine c plus a, that's equivalent to sine b. This will be equivalent to, we have sine a times sine b times sine c. Then we have in the second term sine a multiplied to sine c. So sine c plus a, that's equivalent to sine b. And in the third term, we have sine b times sine c and sine b plus c, so that's equivalent to sine a. Now, three terms are exactly equal, so we get 3 times sine of a times sine of b times sine c. So this is the expression on the right hand side, and hence we have successfully shown that the left hand side of the given expression of the given trigonometric equation, that's equals to 3 sine a sine b sine c, hence proved.